Hello, welcome back. So this is the part 2 of the question on quantum, and it says that derive the expression for the reflection coefficient. Okay, derive from the previous question. We have done that in the last video. Okay, now we have the Schrodinger equation on the board, and this is the solution we got from the previous question, which is the continuity condition on psi prime. This is the continuity condition on psi prime. Okay, so now we are going to solve this problem now. Okay, now to solve this problem, we know that for the two regions, okay, please check out the last video. For the two regions, let me just quickly sketch. This is region 1, this is region 2. V is equal to 0 in region 1 and V is equal to 0 in region 2. Okay, we drew this, but I'm just doing this, and at this boundary x is equal to what? A. Okay, so now that we know that V is equal to 0 for region 1 and region 2, now we are going to be using this Schrodinger equation. Since V is equal to 0, it means this equation, this Schrodinger equation, becomes minus x squared over 2m the square psi all over the x squared. This is 0, right? So it means it's going away. So it will be equal to what? E of psi. Is that okay? So I want this to be on it. This should be on its own. To achieve this, we multiply both sides by 2m over h cross squared. So if we do this, it means we'll have minus h cross squared over 2m times what? 2m over what? H cross. I don't know if you can see this. 2m times minus of this is equal to what? We have this square psi, the x squared is equal to e of psi multiplied by what? 2m over what? H cross square. Okay, so now let's say we are multiplying by minus 2m. There's a minus 2, so this minus will cancel this minus h cross squares will cancel this will go with this minus will go with this minus, and then we'll be left with what? The square psi all over the x squared is equal to what? If we multiply this becomes minus 2me psi all over what? H cross squared. I didn't do anything, I only brought this to this side. It's the same thing. A times B is equal to B times A. So we have this solution. And now if we let k, right, k squared is equal to 2m e over h cross squared, it means this will be substituted with k squared, and then we'll have what? The square psi all over the x squared is equal to what? Minus k squared psi. Okay, now what you have on the board is it has a solution. This function you see on the board has a solution, and the solution is this. Sorry, I'm going to wipe this information, so sorry. So, and the solution is this. Okay, so it means we'll have this solution for region 1. We are going to be having this solution, a exponential ikx, right? Okay, plus b exponential minus ikx. This is for region 1. Okay, so for region 2, region 2 is going to be c exponential ikx. Okay, but mind you, psi 1 is equal to psi 2. Region 1 is equal to region 2. Okay, so it means that if this is equal to this, it means that what? This a exponential ikx plus b exponential minus ikx is equal to c exponential ikx. Let's call this equation 3 because we'll be needing it. Okay, now I want you to know this. For region 1, this is what we have. Okay, region 1, region 2. The incident wave function happens here. The reflected wave function happens here. Only the transmitted gets to this boundary. Okay, so it means in region 1 we have the incident, and then we have the what? The reflection too, or the reflected wave function. And on region 2, it is only the transmitted that is in region 2. Take note of this information. Now I can wipe this. We have gotten our equation 3. Okay, I hope you understand what we're doing. So let me write it up. So equation 3 becomes this. We have a exponential ikx plus b exponential minus ikx is equal to c exponential ikx. Let's call this equation 3. But that's not what we are looking for. But it's going to help us to find what we are looking for. We are looking for the reflection coefficient. So what is the formula for reflection coefficient? The formula is simply R is equal to SR SI, then absolute. Okay, this is the formula. So now what is SR? What is SI? Now the SR, the formula is equal to HIM over M, open bracket, psi, the psi. This is with the dagger. Okay, this is a conjugate psi. Okay, so since we're talking about reflected, we have to put RF, REF, then close. This is the formula we're going to be using to find SR. So let's find SI. SI is also the same formula, H over M, IM, psi dagger, incidence, the psi, incidence. This is the formula. So we are going to break down this formula to find SR. Break down this formula to find SI, and then we'll put it here to find R. Okay, now let's do this. Let's start with the first one. Okay, so I'm so sorry, I'm going to be wiping this information. We'll still rewrite the formula. Okay, so let's find R first. Okay, so if we find R, what is reflection? Everything that has to do with reflection is this. I told you this is what? Reflection. If you still remember what I said before. So this is reflection. This is what? The incident, and this is what? The transmitted. Okay, so now what is our psi? Let's start with the one without the conjugate. Psi R is simply equal to what? B exponential minus IKX, right? So what will be psi dagger? Psi dagger, the conjugate of this will now be what? B exponential IKX. This will not carry a minus sign, okay, because of this complex number that we are having here. It's not going to carry the minus sign. Okay, so now we have this. So what is this? So this, it means we are differentiating psi with respect to x. So since we are going to be differentiating this with respect to x, it means it's going to be giving us minus ikb exponential minus ikx. Now we have found everything. All this information is what we will substitute into this. So now let's break it down. So let's do this times this. So what would be this? This dagger, this psi. What would this be? This is this. So we have b exponential, this is it, right? Ikx multiplied by differentiation of this, that's this. This is what we have here. So we have minus ik b exponential minus ik of x. So sorry, I have to manage my board. I hope we got this, everything here. So let me wipe this side so that we'll continue. Okay, so we have this information now to be this. Okay, so the exponential, remember there's a dagger here. This one will carry its dagger. It keep carrying its dagger. So this will cancel this. I hope you are seeing to this point. This will cancel this, and then we'll be left with, so it means this ref rf becomes b dagger. There's a minus because of this minus. We have a minus there. Minus what? Okay, let me start with the let's take it one step at a time. IKB. So this becomes what? Minus IK. Is that okay? B dagger B. Okay, so now we are done with this bracket. Let's add this. Okay, so this is what we have. This is what we have. Let's add this. So if you add this, this one becomes IM ref decide this. This I will cancel this I, and then we'll be left with what? Minus K B dagger B. Is that okay? I'm going somewhere. So finally, we have SR is equal to HM. Okay? Let's put the minus here. KB dagger B. So, using the same principle, if you use the same principle, just the way we solve this, or you want me to do it, okay? So, let's establish this. We have gotten our SR is equal to minus H over M KB plus B. This is SR. Now, let's use the same method now to find SI, and then we'll come back. The same way is what we are going to, the same method. So this is going to, with SI we're looking for, this will change to I, okay? This will change to IN, and this will change to what? IN. So now, let's start with the simplest, psi in. So psi incident is what? Is this is equal to A exponential IKX, okay? IKX, right? So psi dagger in will be equal to what? A exponential what? Minus IKX. The psi in, so the psi in will be equal to, that's why differentiating psi in with respect to x, it gives us what? IK exponential, okay? This is the coefficient of x, okay? IK, all right? And then we have A exponential what? IKX. Is that okay? So what is the next thing we'll do? We'll find the whole of this bracket. So what will be the whole of this bracket? We have what? Psi dagger in, the psi in, what will it be? Psi dagger in is this. So it's going to be equal to A exponential. No. Yes. Psi dagger in IKX, then multiplied by psi in. No, sorry. No. Multiplied by the psi in. That's the next thing, which is this. So we have IK, I'm copying this, A exponential IKX, right? So what is the next thing to do? This, we go with this, and then we'll be left with what? We have what? IK, remember there's a dagger here. I what? K, we're bringing this out. A dagger E. A dagger E. Okay, so let's further simplify. If we further simplify, that means if I include IM here, like this IM, so we have IM psi dagger in this, right? This I will go, and then we'll be left with K dagger this. So let me wipe this side. So we have found this to be equal to this. All of this, I am dagger in the dagger, I mean psi in the psi in. Look at it. I am, this is equal to this. So if you substitute, it means I, this is equal to what? H over M K A dagger A. Okay, so we have gotten our psi SI. Okay, so it means SI is equal to H over M K A plus A. Now let's substitute into this. So if you substitute into this, we have R is equal to what? SR is this, we have minus H over M K B this all over SI is this H over M K A plus A. Okay, right? So it is absolute, right? So this minus will go, this will cancel this will go with this. Remember, it's the same region, they are in the same region, so it means it will be K1 K1, so it will go, okay, because it's the same region. So we have this will now be equal to what? B dagger B all over A dagger, you remember it's multiplication, this, so it becomes B over A dagger, sorry I missed, it's A dagger A, it now be what? B all over A. Okay, and this is the same thing as, it means that R is the same thing as what? B all over A squared. So but we can't stop here, we need to find this constant. B and A is a constant, we need to find this constant. And how do we find this constant? To find this constant, we are going to be using the continuity, this continuity condition we found on psi prime. That is what we are going to be using to find the constant B and A. Okay, let's do this. So okay, I won't wipe this because we'll need this information. So we have this. I hope we will remember this formula. R is equal to B over A all squared. We'll be referring to it later. Okay, so we have this. So since we have this, we are going to be using this. But before we do this, let me define this thing we have. So it means psi 1 A plus is a wave function after region 1. So it means it is in what? Region 2. So A plus is in what? Is equal to what? Is a wave function in region 2. Okay, and region 2, it means the solution is equal to, for region 2 is simply equal to what? C exponential IKA. Okay, because at this, using the boundary condition, if you still remember what we have, that diagram, x is equal to A, the boundary, for the boundary condition at x is equal to what? A. Okay, at x is equal to A, region 1 is equal to what? Region 2. So A plus is region 2, and so this is prime. A prime, A minus is region 1. okay, is a wave function in what? Region 1. So it means this is equal to what? Wave function in region 1. And this is having a solution a exponential ika plus b exponential minus ika. Is that okay? So now we are going to fill this information into this. Okay, we are going to fill this information into this. Is that okay? Okay, but remember that this prime means differentiation. We didn't differentiate this. I only explained some things you should be familiar with. Okay, so we are going to be differentiating. Okay, so I hope you understand what region 1 is and what region 2 is. So we'll substitute into this continuity condition we found in the last question, and then we'll solve. Let's do this. So this is the formula we're going to be using. We have psi 1. I don't know if we will still remember this formula. We don't need this Schrodinger equation anymore. So let me wipe it and put this here. Okay. Let me put this. We'll be needing this information. IK A plus, it's A, B exponential IKA is equal to C E I K E. Okay, so let me write this so that we can start from the top, so we have enough space to solve. Okay, and mind you, we know that R with SS bridge this, that is equal to B over A squared. We are looking for this constant. Okay, that's the essence of what we're doing right now, to find the constant B and what A. So we know that this is A plus is for region 2, and I said that region 2 is simply what? So we are going to be we are going to be differentiating. It's simply this C exponential I K E. So we're going to be differentiating with respect to x because it's psi prime. It means it's going to be beside the x. So differentiating this, it means we'll have ik here. Okay, so we have minus. A minus is for region 1, and in region 1 we have the wave function for incidence, and we also have the wave function for what? The reflection for region 1. So region 2 is just the transmitted wave function, okay, that we have there. So if we do this, we have for region 1, we have as differentiating, we have these brackets. Okay, my markers are dying. Don't know, I always have this problem. So we have IK. I don't know if you get to see this marker. Let me try the blue color. So we have IK, right? Are you following? IK A exponential IKA, all right? Then plus B exponential minus, there's going to be IK because we're differentiating. So IK B exponential minus IKA, close the brackets. My God. Is that okay? Is equal to this, we have this 2mg h cross squared psi of A. This is the same thing as what this is for region 1 2, but we're not differentiating. So we have A exponential IKA plus B exponential minus IKA. Okay, I hope it's clear. I hope this is clear. So now that we have this, we can bring out IK. Okay, if we bring out IK, we have, if we bring out IK, we have this. Okay, we have this. we have this no, ik is inside here. So if we bring out ik, we have c exponential ika, right, minus a exponential minus ika plus b exponential minus ika minus this one become this times this will become a minus. Is that okay? This will become a minus is equal to 2mg h cross squared a exponential ika plus b exponential minus ika. Remember, there are equals to. My body is not long. I would have concluded it a long way. So we have this. Okay. So now what is the next thing? What we are looking for is A and B. And then we are seeing C here. So what does that mean? It means we are going to be substituting. Okay. We are going to be substituting using the boundary condition. Region 1 is equal to region 2, which is this. Okay. Region 1 is equal to region 2. Okay. We are going to substitute this CEIK with this. Okay. So it means we will substitute this with this. So if we do this, we have IK. Marker, please. So it means we'll have what? IK. Yeah, this is it, right? Into what? We are removing this and we are replacing it with this. So we have what? A exponential IKA plus what? B exponential minus IKA. Okay, we have substituted this, right? Then we continue minus a exponential ika minus b exponential minus ike. Can you see this? So this is equal to this, equal to 2mg all over what? H cross a ika plus what? B exponential minus ike. Okay, so what can we do? Yes, so minus so something minus a exponential something is supposed to cancel out here. Am I missing something? What have I missed? What have I missed? Okay, I hope you are seeing what we are doing. Ow, 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 ow. There's something that I'm trying to figure out here. I hope you're on the same page with me. I hope you're on the same page with me. I hope you're on the same page with me. Um, Let's see. Aha. Yeah. I think when we differentiated this, it came with a minus. So this will be minus. This will be minus, and then it will be a plus here. Yep. Yeah, it will be a plus here. Minus, it becomes a plus here. Then it will be a plus here. Okay. So uh, minus. So this will go with this, right? This will go with this, and then we'll be left with ik into this. We have what? 2b exponential minus ika, right? Ik 2b exponential minus ika. Yeah, 2b exponential minus ika, right? So is equal to 2mg all over h cross squared into a exponential ika plus b exponential minus ika. Sorry, I wiped the upper parts. I think we're through with this. I wiped this part. I don't think we need this information too. Okay, so I'll bring it forward. We have ik into 2b exponential minus ika is equal to 2mg h cross squared a exponential ika plus b exponential minus ika. Okay, if we divide both sides by 2, we'll be left with ik b exponential minus ika. Right, let me use the same kind of brackets, is equal to 2mg h cross squared a exponential ika plus what? B exponential minus ika. Right? So what next? This 2 is gone. This 2 will go. We have mg left. So let's bring this to this side. Like we multiply this side by h cross squared over mg, multiplies this side by h cross squared over mg. It means this will be eliminated on this side, and we'll have what? mgik all over h cross squared. Am I correct? No. It's going to be what? I h cross k. That means this will come here, right? And this will come down. We have mg into b exponential minus ika is equal to, it will be eliminated because if we multiply by h cross over mg, it will go. So we'll be left with what? A ika plus b exponential minus ika. Close the bracket. So this is this. What next? Let's bring this, remove this bracket. Let's move this bracket so it looks simpler. If we bring this to this side, okay? If we bring this to this side, it becomes this k over mg b exponential minus ika minus b exponential minus ika is equal to what? A exponential ika. Okay, let's bring this out. If we bring this b exponential minus IKA out, we have this left, h cross squared k all over what, mg, right? If this thing comes out, this will be left, then this will be 1 b exponential minus IKA. So it brings us back to this times this will give us this times 1 will give us this, equals to what, a exponential IKA, right? So what do we do next? Let's multiply both sides by exponential. We want to eliminate this exponential on this side, so we multiply both sides by the conjugate of this exponential that is here, that's multiplied by the positive. So it gives us this, we have I h cross k over mg minus 1 into b. Okay, if we do this, ik times IKA positive, a exponential IKA times exponential IKA, it brings us to this will cancel this, and then we'll be left with what, h cross k over mg minus 1, okay, b is equal to what, a exponential, this will sum up, okay, it will now be what, 2 IKA, okay, it won't cancel out, it becomes 2. Just assume this IKA is 1, this and another 1 plus 1 will give us 2. Okay, so now me wipe this upper part and then we'll continue from there. I hope you are seeing what I'm doing. I hope it's clear. So let's bring this up forward. We have I h cross k minus 1 over mg, we close the bracket, b is equal to a exponential 2ik. Okay, so if we have this, the essence is to get this bar b over a, that's the idea. So just I will explain. I want to have b over a, so this is what I will do, b over a. Okay, so now to come back to this, it means this one will be here. Okay, it will now be what, I h cross k over what, mg, okay, minus 1, close it, right? Then if you multiply, it comes back here. So what am I going to multiply with this to give me this? I will be multiplying with this 2IKA. Now we have gotten our BA. Okay, so now our reflection will now be equal to B over A, right? You remember, times what? B over what? A. Dagger. Okay, let's put the dagger on this, the conjugate on the other side. So we know that this is the formula, right? So I want to use this, since we know that this is B over A now, this is B over A. So we are going to be multiplying it now by the conjugate. So we will have exponential, okay? This will now be what? Minus 2ik, because it is having a complex number, so the sign will change. So all over, this also is having a complex number, so we have what? Minus, okay, I h cross k all over what? mg minus 1. You are not changing the sign of this because it's not having a complex number. Okay, so this is it. So we are going to be multiplying it out to find our reflection. Okay, so our reflection coefficient will now be equal to, okay, so if we multiply this out, our reflection coefficient will now be what? This will cancel this, it becomes 0. Okay, just assume this is a, this is minus a, it will be 0. Anything raised to power 0 is 1, so we'll be having 1 all over. Okay, so we have I there. I times I itself is minus 1. There's a minus 1 here, so it becomes positive. Okay, so it becomes positive 1. There's no need to write it. Sorry, I missed something very important. I don't know how I missed it, but it's h cross squared, please. I don't know how I missed it, but it's h cross squared. I don't know how I missed it, but it's h cross squared, please. So h cross squared times this, okay, it gives us what? H raised to power 4, h cross squared 4. This times this will give us k squared. M times m will give us all over m squared. G times g will give us g squared, please. G squared. Okay, 1 times 1 will give us 1. Will give us plus 1. Minus 1 times minus 1 will give us plus 1. And this is what? The reflection coefficient. Okay, I hope you enjoyed today's lecture. Bye.